How a jet engine is made, from raw metal to flight. Imagine a machine so powerful that it can lift a 400-ton aircraft into the sky, and yet it starts from nothing but raw metal. This is the story of how a jet engine is made. Every bolt, every turbine blade, every spark of fire, crafted with precision that borders on perfection. In the beginning, it all starts with an idea, an engineering dream to conquer the sky. The concept is born inside the mind of an aerospace designer. For months, teams of scientists and engineers design every curve, every airflow passage, using advanced 3D simulations and wind tunnel tests. Because in the world of aviation, even a single miscalculation can mean the difference between flight and failure. The process begins deep inside foundries, huge industrial facilities where tons of nickel, titanium, and chromium are melted together. The temperature inside these furnaces reaches over 1,600 degrees Celsius, hot enough to turn solid metal into glowing rivers of liquid alloy. This molten metal is poured into giant molds, shaped into the rough forms of compressor discs, turbine blades, and casings, the skeletal parts of a jet engine. But the real magic begins after this moment, because the secret of jet engines lies not in raw power, but in precision. The metal is cooled under controlled conditions, creating microscopic crystal structures strong enough to withstand temperatures hotter than a volcano's core. Each piece is then forged under hydraulic presses that can crush mountains, shaping the metal into forms so aerodynamic that even air seems to flow willingly across them. Now, imagine this. A single turbine blade must endure over 1,000 degrees Celsius and spin more than 10,000 times every minute. If it fails, the engine fails. That's why every blade is treated like a diamond, polished, balanced, and tested with laser accuracy. These blades are not just components. They are pieces of art, carved by fire and science. And so begins the transformation, from raw metal to mechanical life. But behind this glowing furnace and thunderous hammer lies the quiet heartbeat of human craftsmanship. The engineers who check every curve, the metallurgists who study every grain of alloy, and the dreamers who still believe that flight is humanity's most beautiful achievement. Now let's move deeper into the heart of the engine itself, where air, fire, and force merge to create thrust. Inside the manufacturing halls, the journey continues. Giant CNC machines, taller than a human, start carving each forged piece to microscopic accuracy. The core engine parts, compressor discs, turbine rotors, and combustion liners are sculpted with diamond-tipped tools that move smoother than a heartbeat. Each cut, each groove, each hole, calculated to thousandths of a millimeter. The air that will pass through these parts moves faster than the speed of sound. And it must move perfectly, or the engine will never fly. Now, the heart of the engine begins to take shape, the compressor section. This is where air enters and gets squeezed, compressed to nearly 30 times atmospheric pressure. Layer by layer, rows of blades are assembled. The fan, the low-pressure compressor, the high, each spinning faster than the one before it. It's like an orchestra of motion, every blade playing its part in harmony. Then comes the most sacred chamber of all, the combustor. Here, air meets fire. Jet fuel is injected with perfect precision, igniting into an explosion that happens thousands of times per minute. The temperature inside this chamber reaches 1,700 degrees Celsius, hotter than the melting point of the metal itself. So how does it survive? The answer is genius. Engineers use tiny cooling holes and special heat-resistant coatings to create a thin film of air between the flame and the metal. The result? Fire that never destroys its own heart. Beyond the combustor lies the turbine, a series of spinning blades that capture the energy of fire and convert it into rotation. This is the moment when the engine becomes alive. The turbine spins the compressor, and the compressor feeds the combustor. A perfect loop of motion and energy. A cycle that has powered humanity's dream to fly. At this point, the engine is no longer a machine. It's a living system of controlled chaos. A dance between air and metal, designed to work together at the edge of physics. Now, let's move toward the final stages, where this heart of fire is assembled, tested, and prepared to touch the sky. When all components are ready, the fan, the compressors, the combustor, and the turbines, the real art begins: assembly. Engineers in clean, climate-controlled rooms start joining hundreds of individual parts together. Every bolt is torqued with laser-guided tools. Every bearing is balanced with digital sensors that can detect a fraction of a gram. Imagine the care. One small nut out of place can cause vibrations strong enough to shake an airplane mid-air. So every engine is built like a watch, with patience and pride. Large robotic arms help lift sections weighing several tons, placing them together as if solving a giant 3D puzzle. The fan blades, enormous yet feather-light, are mounted at the front, perfectly angled to slice through the air. Each stage of the assembly is inspected and re-inspected. Engineers use ultrasound, X-ray, and infrared scanning to detect even invisible cracks. Space. And then the magic moment, the first spin test. The engine is mounted on a test stand and rotated by electric motors. Sensors monitor every vibration, every pulse, every whisper of air. The team holds its breath. The sound builds up, a deep whine growing into a metallic roar. But this is only the beginning, the dry test. The true test comes next. Fuel is pumped in, ignition sparks, and suddenly, fire erupts. The engine screams to life, its blades spinning faster than the eye can follow. Temperatures soar, pressure builds. The entire test cell trembles under the force of controlled thunder. And yet, amid all this power, the readings stay perfect. The roar smooths into harmony. The engine is alive, strong, stable, balanced. For the engineers watching, it's a moment of quiet triumph. Years of design, metal, fire, and patience, now breathing in unison. Next, the engine is cooled, inspected once more, and polished until it gleams like liquid silver. Now it's ready for installation, ready to fly. Now, imagine this: a brand new jet engine being transported through the night, mounted carefully inside a massive aircraft hangar. Technicians in reflective suits lift it gently under the wing of a commercial airliner. Bolts are locked, fuel lines connected, sensors calibrated. For the first time, the engine meets its destiny, the sky. Before it can fly passengers, every engine must prove itself through brutal trials, altitude simulation, temperature extremes, and vibration endurance tests that push it to the breaking point. It must perform perfectly at -50 degrees Celsius, and also under desert heat. At full power, it consumes nearly a ton of air every second, turning fuel into thrust that can lift a city bus with ease. Once installed, the aircraft rolls out to the runway. Pilots power up. The engines spool slowly, their hum turning into a deep growl. The thrust builds, air pressure rises, and then lift. A giant of metal leaves the ground, carried by forces born from molten alloy, precision engineering, and human ambition. Look at that moment. The wings slicing through clouds, the engines glowing faintly under the sunlight. It's not just technology, it's a living proof of what mankind can achieve when imagination meets science. Each flight you take, every journey above the clouds, begins here, in the quiet factories where engineers and dreamers work together to build something that defies gravity. Every bolt tells a story of patience, every flame a story of courage, every flight a story of faith in human hands. Now, as the plane soars into the horizon, the engine whispers its own story of fire, air, and the endless desire to go beyond. A jet engine is more than a machine. It's a symbol of humanity's eternal quest to rise higher. It combines the brilliance of science with the soul of creation, from the roar of its turbines to the silence of its glide. In every takeoff, there's the heartbeat of countless people, metallurgists, machinists, designers, pilots, and dreamers, all united by one goal: to make metal fly. Today's engines are marvels of engineering, efficient, intelligent, and powerful, but they stand on the shoulders of generations, from the first propellers of the Wright brothers to the roaring jets that now cross oceans in a single night. And yet, even now, engineers continue to ask, how can we make it lighter, faster, cleaner? From hybrid electric propulsion to hydrogen engines, the next revolution is already in motion. But no matter how advanced engines become, one thing will always remain: the human desire to push boundaries, to take metal, melt it, mold it, and give it the gift of flight. So next time you see a plane cutting through the clouds, remember, beneath that calm sky lies a roaring heart of fire, born from earth, shaped by hands, and perfected by science. This is how a jet engine is made. This is TechNerve.
If you love discovering the power behind the world's greatest machines, then don't just watch. Join the mission. Hit subscribe, tap the bell icon, and stay connected to TechNerve, where technology comes alive.
Which machine should I next?